Vernier has had a dynamics cart and track system for some time. In our revised version, we've taken all we've learned in using those carts and tracks with students to create a system that's ideal for teaching dynamics and kinematics in the introductory physics classroom. Let me walk you through some of the features of our carts and track. The carts have extremely low friction bearings. There is an anti-roll peg that keeps the cart from rolling off the lab table when it's simply placed there, but you put it on the track and it's free to roll. The ends of the cart have easily removable tabs where you can keep magnets or hook and pile tabs for doing different kinds of collisions. The top surface of the cart is well labeled so that the student can attach sensors such as the dual range force sensor, the low G accelerometer, or the wireless dynamic sensor system. For example, I can take a dual range force sensor, is placed on the top surface, and the supplied bolt can be driven in, and now I've attached a force sensor to the top of my cart, and it's securely in place and won't shift during the course of an experiment. The top surface of the cart also includes 4 mass trays. I can take a mass, put the mass in the mass tray, and change the total mass of the cart without having to remove my dual range force sensor. This way a student can do experiments looking at how the mass of the cart affects the dynamics and kinematics. I'm going to remove these and then show you the features of the plunger cart. Now, the plunger cart is a different color. We did this intentionally so that in discussing collisions, students and teachers no longer have to say this cart and that cart, or my left and your right. We can simply talk about the gray cart or the green cart. The plunger cart is set up so that you can do a variety of collisions. One interesting feature is that it's able to do superelastic collisions, where the plunger extends on contact to the 2 carts. So I can set up for a collision between the 2 carts and have the spring add energy to the system. I'll let the 2 drift together slowly, and the plunger extends suddenly. That adds energy to the system. It doesn't change the momentum conservation. There are other pieces that come with the dynamics cart and track system. For example, many times physics instructors want to use a pulley with a photo gate attached to the end of the track. The dynamics cart and track system comes with a bracket and a pulley so that you can add your photo gate and do experiments such as a half-Atwood's machine. The system is available for use both with a motion detector, the standard ultrasonic motion detector, or Vernier's unique and innovative motion encoder system. The motion encoder system has a cart that includes a sensor on the underside of the cart. That sensor sees the bars that are printed on the top surface of the track pass by, and that information is sent back by an infrared beam to a receiver at the end of the track. This allows the system to record the motion of the cart as a function of time very cleanly, with no problems from stray reflections from other equipment in the laboratory. Let's do a quick experiment showing how a cart on a ramp will work with the motion encoder system. I'm going to convert this track to a ramp by removing this foot. Now let's do a quick experiment studying the motion of the cart as it rolls up and down the ramp. So I'll start data collection in Logger Pro, give the cart a push, and allow the cart to roll back down and stop it. You see very clean data. The position versus time graph shows only the motion of the cart. There are no extraneous spikes from other things going on in the classroom. The velocity versus time graph has a nice linear segment while the cart is freely rolling. And the acceleration graph is usable as well, showing constant acceleration as the cart was freely rolling on the ramp. The one thing that you almost never do in the physics classroom when you use motion detectors is talk about the derivative of the acceleration. This is a quantity that's known as jerk, and with a motion detector, you rarely get useful data. I can change my acceleration graph to a graph of jerk, and let me rescale that, and you see that even the third derivative of the position as a function of time is a useful quantity when collected with the Vernier motion encoder system. The Vernier Dynamics Cart and Track system is actually an entire ecosystem of physics education material. We have additional components that can be used with the carts to study other phenomena. For example, I can pull my magnet tabs off of my cart and insert a friction pad. That friction pad has a piece that rests on the track, and now I've got a cart moving with additional friction, and I can study that phenomenon. We have other pieces available, such as the bumper launcher kit for doing momentum impulse experiments. We also have a variety of optics components that attach to the top of the track. We have thin lenses, we have mirrors, and we have a diffraction apparatus in addition to a color mixing system. So the Vernier Dynamics Cart and Track system gives the physics teacher a whole array of equipment with which to teach first-year physics.